last year, so I've actually spent more than a year trying to gather and condense thoughts on this. So I'm quite excited about all the content that we've got on the table for us today. My name is Steve Taylor. I am a principal systems engineer over at ITI Group. We're kind of an industrial digital systems provider. And personally, I am an Aviva Pi system specialist. So I'm a specialist in Pi AF and Pi Vision and technologies like that, other real-time technologies. But what I'm trying to do today is to, although I'll use examples from that framework, but I'm trying to make it as wide and applicable as we can. So by background, I've got a degree in computing and a degree in applied theology, both useful in different places, and also 15 years in and around the energy sector. So I've worked with quite a few major oil and gas companies. I had a couple of years with CNOOC, the Chinese National Offshore Oil Corporation. I've had quite a few years with supporting BP's global analytics projects. And on the whole, between them and other companies, I've audited and coached around 10 global analytics projects. And so the idea is to be able to kind of take some of that and help others learn from the experience there. So in my first role over at CNOOC, I was sat next to a metering engineer. In fact, I sat next to 3 different metering engineers over a couple of years, and they all went out of their way to teach me all about the importance of fluid and gas measurement, different sensor types and why they were important. And that really helped me to get where I am later in my career. So today, although I'm not a member of the Institute of Measurement and Control, this is today my opportunity to repay a little bit of that. So yeah, let's get going. So what can you expect from today? I recognize for the majority of people here, you are probably not responsible for managing any digital project, but chances are you will be involved in quite a few during your working life, and you might really be instrumental to their success. Let me move that off so you can see a bit clearer. So the goal here is that by the end, you are significantly more effective in supporting, influencing, and shaping digital projects, and specifically around anomaly detection. We're going to look at why big projects fail. We're going to look at being digital project ready, being user experience ready, and being scale up ready. And basically, we're not going to spend a lot of time looking at the nuts and bolts of building calculations. I've got a lot of confidence in anybody in the room here that you could build a good and successful proof of concept. But the challenge is scaling that. For really decades now, more than 20 years, it's been known that around 50% of all IT projects fail to deliver the expected benefits. And Harvard Business Review have recently released a report saying that around 80% of AI and machine learning projects fail to deliver their intended goals. So in all the types of new things people are doing today, the failure rate is still really, really high, and that's a lot of wastage in value. So how do we reduce that waste? So why do big projects fail? Turn to the NHS. When their national IT programme failed, the post-mortem showed this. They had a lack of clear vision, a lack of understanding of where the project stopped, and so it grew and grew and grew until it wasn't manageable anymore. They had poor stakeholder management. They didn't talk to the people who were invested in and needed to use the platforms, and that led to poor user adoption when they began to roll out different parts. They tried a one-size-fits-all approach, thinking one hospital is the same as any other hospital, and that doesn't really work that way. And they had various issues getting tech to talk to each other. And then also the vendors they had kind of locked them in, and they struggled to get out. Flip over to smart meters, a little bit closer to home. In all kinds of smart meter projects globally, there have been a lot of recurring issues. Although we understand very well the issues or really why smart meters are good for global energy providers, but what is the value for the end customer? That's challenging to explain. That's led to poor user adoption. They've struggled to integrate them with existing systems. The technology and standards around them all is quite immature, and so they've not managed to make it work effectively at scale. And there's all sorts of issues around data handling, security, and logistics. And so if you compare the two side by side, there's a lot of commonality. And this goes to pretty much all tech projects, including all kinds of analytics and anomaly detection projects. You got to know what it is you're trying to do, You've got to manage your stakeholders, make sure everybody's involved that should be involved. Think about user adoption, getting people involved early, and make sure that you can connect with the existing technologies, systems, processes that you have in place. So there's a lot of commonalities here. And so before we get going with the kind of the core stuff we're looking at today, and before you get going with any project, here are 5 questions you need to answer. What problem are you trying to solve? Pick your battle. Beware that risk of scope creep. Decide what you're going to do, what you're not going to do. Who's affected? Are they on board? All the people who will use it, the people who will use the data from it, the people who will put data into it, the IT teams that will support it. Do you have all the people involved who really need to be involved? Watch out for failure to adopt. Has it been done before? And this is a big question, actually, because you think, no, oh, of course not, Steve, but we've not done this before in our company. That's why we're doing it. But actually, there could be a lot of transferable knowledge that you can pick up on. I tried to explain this to a colleague of mine. He works in simulation. So whenever they do like physical infrastructure projects, they do like a simulation model to figure out, is it going to work? So an example he gave me was like a warehouse. The company needed to move from a small warehouse to a big warehouse, and they did all the calculations in Excel. They figured out how big does it need to be, and they had all their planning done. But before they pushed play on the project, they came to us, did a simulation project. Can you model our warehouse with all the processes and systems and goods in and goods out? And when we modeled it, it turned out that their proposed warehouse was maybe 3 times too small, or rather had to be 3 times bigger to fit the needs that they were proposing. So that's great for a physical project, but for a digital project, you can't really do that. You can't physically model all the people you have to talk to, decisions you have to make, and the digital grunt work in making it happen. So it's pretty tough. If it has been done somewhere successfully, that's a good sign, but have we done anything like it? Are there any similar projects that have affected your team before, or have been done elsewhere in your company that you can learn from and figure out, what are the risks? And then what kind of governance and standards will we need? And usually you approach this kind of question and people will shoot you for asking the question. Like, just let us get on with it. We don't want to worry about governance and standards and things like that. But actually, this will slow you down. Do not underestimate it, especially in a large organization. Any decision, every single decision around governance, standards, platforms is a hill that somebody is willing to die on. So you got to make sure that you know upfront, who do you have to talk to, who owns the data, who owns the systems, and who do you need to have on board to get things moving. So be digital project ready. How can you build at the heart of your analytics to scale? First of all, start small. Don't go for the entire site, the entire project. Compartmentalize it. Make it a small start so you can prove that it is doable and that it delivers the value that you expect. Lean into areas of strength and interest. So you need energy to get any project going and to complete it. You need energy. And so it's going to be tough. You're going to have to keep going. And even if you're looking at me saying, Steve, I don't have a lot of energy, that's just not me. Maybe the right word is conviction. You got to have conviction that by doing this project, it's what we need to manage our assets effectively, to manage our sensors, to get the business where we need it to go. Just that conviction, this is what needs to happen and we need to get there. Once you have that energy, that conviction, what kind of support do you need to get the commitment from other people that you need? If you're going into other realms of engineering, if you need to get electrical engineers, mechanical, process, IT guys, management, whoever you need on board, make sure your team has all the right people you need to make sure you can unblock issues and keep things moving. You don't get stuck waiting for that other team over there to do something because you've got all the skills that you need within your team. The same goes for anything that you can't get an expert for. Like, let's say you can't afford a full-time expert in one thing or another, make sure you secure that availability that when you do have questions, you can go to them for help. This is a common one in technology because what you don't want a simple technical thing to lose 5 hours of time trying to troubleshoot and figure things out, when if you just had an expert on hand, they would solve it in 5 minutes. And then to delegate what you don't need to do yourself. So all the ways to kind of start small and keep going as quickly as you can. And it's worth thinking about your tooling. Whatever you're trying to do, whichever technology you've picked up to do it with, research it. Try and figure out what are all the things that we will need to do by the time we're finished, and is the tool capable of doing that? And say if you need help, find an expert, find somebody who knows about the technology to help you understand, and you don't get halfway through the project to realize actually it's not achievable. So, get into the actual the core of it all. When you're actually building logic to understand equipment health and anomalies, it can be tempting just to write it all as one big thing. And this is my compressor analytic, and then you can use that for every compressor. But that can be tough, and there's actually lots of questions in there. If we have vibration sensors, are they behaving normally? Is the lube oil system functioning normally? Are the seals healthy? Is the filter healthy? Is the system performance of my compressor running within the design boundaries? Do I know where those design boundaries are? Do I know where they are for all the other compressors I'm planning to monitor? Are the temperature sensors reading normally? There's all kinds of questions that you may have for your equipment. And really, to be most effective, you want to try and compartmentalize that. Instead of just doing compressor health, actually, why do we do 5 different smaller analytics here? We've got one for our seal performance, one for compressor performance, one for filter health. We've got a calculation for dealing with the ops envelope of an individual sensor, or maybe the normalized health of that sensor. By compartmentalizing, you're able to pinpoint, what is healthy, what's not healthy, clear indications of health and failure. And also, it gives you reusable logic, because maybe you've only got 3 compressors in your site. Maybe you've only got 12 in your organization. But when you begin breaking it out like this, you can actually reuse all the components. So maybe I've got 12 compressors and it'll take forever to do them all, but actually, I'll spend 2 days building filter monitoring, and actually, it's quite easy to find all my filter tags. And so in a week, I can have filtering up and running for all of my filters across the site. And it's the same for each of these, thinking beyond just what's my immediate equipment and thinking, what are the common or reusable things in here that I could pick up and use elsewhere? And it helps you to target that value, that maximum value of reusing the things that you have. So thinking about boundaries for a second. When you're monitoring any kind of equipment health, we're tempted to go back to the same old default limits. You've got your safe design limit, your safe operating limit, your normal operating limit. And usually, if you give it to an IT guy, that's kind of where it ends. Let's just measure your normal operating limits and we'll tell you when you're failing. But actually, for most types of sensors, you can get much earlier indications of failure. And so I've got to credit this particular example to a gentleman named Rob Sutton, who is a human factors expert based down in London. But we had a lot of good conversation around this, around the need to be able to draw the tightest appropriate boundaries around any signal so that we can actually detect all kinds of positive and negative deviations that may tell us different types of things about our equipment. And so rather than just saying that my temperature sensor is reading 73 degrees, let's normalize that. What is it normally? Is it normally 73? Is it normally 63? By being able to tell the deviation from the normal behavior, we can get far earlier indications of failure, even to several weeks earlier than you would get otherwise just waiting for that normal limit to be breached. Now, this opens a question, like, how do you know what's normal? How do you decide or determine it's not going to be the same for all things? If you look at that noisy signal on the right-hand side there, in the background, you've got a line behind it. That's the kind of normal signal that we're comparing it against. And during the life cycle of this monitoring analytic, that limit has changed a couple of times. On the left-hand side of the trend, you can see that it's changed quite regularly. We used to have, self-updating kind of normal readings for this sensor based on the history. And so it would update itself. But then we found actually for this particular sensor that wasn't the right thing. And so we set it back to being more of a static value for this particular set of conditions. So the question is, what should the normal signal actually be? Is it a fixed number? Is it an average or median value? Is it a user-specified value? Does it come from another application or another sensor? Then once you actually have your normal value, how will you handle it when that normal behavior needs to change? This is actually a surprisingly common issue with digital projects, that you design it to be right when you deploy it or when you start, but there's maybe not a lot of thought put into what does a long-term situation look like? How do we continue to update our calculations and methods and KPIs kind of month by month, year by year? Who changes it? How do they change it? How will we manage the history of the behavior and who changed them? So you've got to make sure you've got the right tools in place to be able to continually update it and make sure that your monitoring strategy continues to be good. I'm going to pause and just think about governance and standards. So about 10 years ago, IBM published a study showing that $3.1 trillion was wasted from the US economy each year due to poor quality data. That is a phenomenally big number. What does that really mean? That is $10,000 for each man, woman, and child in the country. Basically, however much you want to quibble about the numbers, we underestimate this. We underestimate the value lost in all of our companies around poor quality data, around lack of usage of data, and data management in general. And so, although you want to try and scope it and make sure you don't do things you don't have to during your project, your big projects are also often the opportunity to fix these problems. Make sure that you're naming things consistently, not duplicating names. That you're controlling what kind of characters and metadata you're using. I've seen entire projects fall down because somebody uses a Cyrillic C instead of a Latin C, and then the tool can't handle that or doesn't process that in the predicted way. You've got to manage these things and take care how people are putting in data. I've seen issues where, like a chemist somewhere in Spain or Eastern Europe puts in an E with a new flicky symbol and the entire thing grinds to a halt. You've got to make sure that you are owning the data and that you know who is responsible for owning the data. Make sure that you're able to kind of share the benefits of the project and not just get stuck fighting over who does what. You've got to manage your units of measure, data quality, architecture, resiliency, security. I'm going quite fast here, but I recognize a lot of these things may be outside your area of control, your area of interest. But the thing is, for any project, any digital project, you just got to make sure it's covered. Somebody somewhere has our back on this and that it is being managed. So in practice, what does this look like? When you cross from one site to another, one of the most common issues is units of measure. I've got an example calculation here that if the engineering unit is degrees Celsius, then do this, otherwise do that. And then you get to your next bit of equipment or your next site, and each sensor you get to has the engineering units described in a different way, in lowercase or uppercase with one space, two spaces, dots, whatever. And this is where we begin kind of eating the damage from other people not standardizing things effectively. That over many years we've gradually built up this legacy of poorly managed metadata that causes issues when you try and scale your project. Thinking about volume calculations for a second, you might build a standard volume calculation and then you try to scale it. You go to Europe and your tags are measuring in liters. You go to the US and your tags are measuring in gallons. You go to other sites and sensors and you get different variants of these units. I've seen in one project they were trying to measure the performance of heat exchangers. You think, great, how much simpler can you get than a heat exchanger? You got kind of a process medium and an exchange medium. You've got inlet temperatures, outlet temperatures. There's not a lot to overcomplicate there. And yet, due to different units and different combinations of what's available and what's not, they ended up with more than 40 different templates trying to manage this complexity. And so you got to get it right and figure out, how do we scale these things across different sites? So first off, standardize things as far as you can. If you see things that are a mess, raise the flag, figure out how we're going to sort this mess out. It can feel like a bit of grunt work, cleaning out and aligning your units of measure, but it pays dividends. It allows projects like yours to build quickly. And actually, for every new digital project that comes along, they will continue to build on your success. So you've got to standardize as much as you can and make sure you know what your conversion factors are and that they are agreed, they are standardized for your organization. Once you've got some standards, it becomes much easier to build engineering unit agnostic calculations. So here's a really simple method that we tend to follow. So just ABC, simple as that. A, take your input unit, convert it to a standard. Great. B, perform a standard calculation. C, take your output and convert it to the required unit for that locale, for that site, for that region. And so very quickly, you're able to build really simple calculations. We managed to bring that 40 different versions down into one single template that worked across each site, each region, each unit, and by managing it in this way. And once you've got it the way you want it to be, make sure that you have governance in place to avoid any future divergence in how you're managing things. So this is just units of measure, but it's an example of the wider kind of governance problem. So before we move on, in summary here, to get the core of your project right, start small, contain the scope, compartmentalize your logic, and use simple core elements. Make sure you think about governance and standards right from the beginning, involve all the people you need to, consider how the calculations might need to change across different sites and regions, and watch out for any possible issues you might encounter that inhibit the scaling and might cause issues. And you got to figure them out and sort them out as early as you can. Now, thinking about user experience, the front end of your tool. As we saw in the examples at the beginning, one of the biggest dangers is failed adoption. You might build something that works perfectly well, but nobody uses it. Or you might build something that really doesn't work well because nobody uses it. Make sure that you and your team are on board. If you're involved in a digital project, everybody who is going to be using it should be on board as far as you can practically get them. Get other people on board, get management, get stakeholders, get other teams involved whenever they need to be. And make sure that you're testing the project and providing feedback as quickly as you can. Actually, testing them is one of the main reasons that projects can cost a lot more than they should, because it takes a while building the project, and then you get ready for testing, but actually the testing takes longer than you expect. Then you feedback what's wrong with it, and it takes a long time to get it fixed. And basically that time between the first version and the final version of the analytic can be quite long if you don't have fast testing going on. And you've got to make sure that you engage your stakeholders all the way through. So why is user adoption tough? Why is it hard? First of all, it could be that the old solution is actually better. Unlucky. So your new solution is missing features. You didn't scope out the requirements correctly. Maybe it's not useful. You got to make sure that not only you have a good tool, but it fits with the business process. You've actually got a way of using it that fits with how people really work and the tools that they actually have to use. Or if you've not tested it well, maybe it's wrong. Maybe it's not being built correctly at all, and you get kind of poor reputation and you struggle to get people on board. It's always it's a pain. It could be that you do genuinely have a better solution and people still don't want to use it. They've got a lack of ownership. They still prefer the old tools. They got a sense this is mine. I put a lot of work into it. I'm going to keep this. It could be that it's not interactive enough. That actually, although you've got a good dashboard, people look at it and maybe things are wrong. They don't know how to change them, or they need to update things and it's just a bit too hard. And they've got to raise a change request every time they need to change a simple limit and things like that. These are all things that just prevent people from using the tools. And so you need to make sure that all the way along you bridge any divides, any gaps, any silos in your organization, especially between yourselves, the engineers, and like the IT guys that are doing various bits. That everybody who got involved is happy talking about issues openly, and you're able to make progress and not end up fighting over them. So thinking a little bit about user experience, I could talk on this one all day long. I'm going to keep it as short as I possibly can. But effectively, we're in a situation where our displays become larger and more complex, and more data is being generated as our technology improves. But We don't often build our tools thinking about that end user experience. And so you can overwhelm people. You can create so many, colors and shapes and indicators everywhere that you overwhelm people and they actually miss things. They miss the real problems you're designing the tools to spot. And you can lead to indecision and missed excursions. People just don't know what to do because they're getting conflicting information. And the fact is that our standards have moved on tremendously. In the last couple of decades, we've got, ISA 101 and other modern equivalents that kind of give us really clear guidelines on making displays clearer and simpler and safer to use. On the screen here, you've got an example of color blindness, deuteranopia. About 1 in 12 of men and 1 in 200 women possess some kind of color blindness. And that can cause an issue. You only, if you are somebody with a full visual color capabilities, that's how you build your tool. You won't often think about the other people in your team that might have other needs. So you got to make sure that whatever you do is fit for purpose for everybody. So when you begin building visuals and dashboards, you got to think about, how do I keep this clear? How do I avoid colors and shapes really just crowding out and making it difficult to understand what's going on? Am I putting the key information in that top left-hand zone that people instinctively look at when they open the screen? What is going on at a glance? Are we answering that question instinctively? Are we giving information in a prominent place that answers key questions? I mean, the number one question for this particular dashboard is, how far off are we from the amount that we have committed to deliver on this date? So how far are we from today's nomination? And so in bright blue, the bigger that delta becomes, it becomes a brighter and bigger blue signal on the screen that drives that user attention. Then when you see what's wrong, you've got clear, actionable links to go to where you need to go next to resolve the issue. So it's all about thinking, for anything you're building, how do I keep the important stuff front and center? I've got another example here from a filter monitoring system. The customer had 8 different identical filtration skids. They're quite complex. They've got kind of self-cleaning mechanisms and things, and they were struggling to monitor and clean them effectively without wastage, without either wasting too much chemical by over-cleaning or getting poor health by under-cleaning. So this dashboard is designed to kind of instinctively help the user understand what's going on. So first of all, we've got a roll-up. This is the same little coloured flag that will appear on any high-level dashboards. It tells us this filtration skid needs attention. When you click in, you come to this screen and, well, what's going on? We've got a bright red and a bright yellow indicator. One's showing us that our key filtration metric is, way down, and then the other one's telling us that we've got too many cleaning cycles happening per day of one of our types of backwash. Front and center, we've got this kind of high focus area on the key metric. This is the number one metric they should be looking at. And it's showing us really a story here. Over the last couple of days, we've seen permeability going down, 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 down. It just begins to touch our soft limit, and then bang, somebody's taken it offline to do a more thorough kind of clean and repair on it. And so it's enabling us to catch and deal with the issues at the appropriate level. On the right hand side, we've got metrics around each of the cleaning types and how effective is that cleaning type being. It helps them to compare the different cleaning types between skids to see, yeah, this type is this effective on that skid, it's that effective on the other skid, to be able to compare and contrast and understand what needs their attention, how to resolve it. And then the rest of the screen is other KPIs, other metrics, and other data that they can use for helping to get to the root cause of these issues that we're seeing above. So again, it's answering those key questions of who's using the display, what questions are they needing to answer, and what do they need to do next. So in a nutshell, it's all about delivering visuals successfully. You've got to consider user adoption at every stage. Who is using it and are they on board? Keep it simple. Follow all the modern guidelines as far as you can. Keep it, don't use color unnecessarily. Try and make it colorblind safe if you can. I've got loads of slides I'd love to show you on that. And don't just replace what the old tool did. Make sure that you're building it for what it needs to be today. You've got to design it intentionally. Build your visuals with a really clear purpose, build thinking about the workflow for what people actually need to do as part of their job, make it accessible, make it interactive. A lot of the newest stuff come out is talking all about, gamification. Can you give somebody points for intervening? Can you find ways to hook that usage of your tool by people by making it more kind of gamified? So there's lots of interesting directions people are taking these things these days. On to our last section, how can we be scale up ready? So why is scaling projects challenging? So you've done it. You've built your first analytic, you've built your visual that goes with it, and it works. It's doing the job. And wow, that was really, maybe it was easy. Maybe you knew what it was going to do and it was all really easy to do. Maybe it was hard, far harder than you thought it would be. But either way, you think it just gets easier from here. I've done it once, I've just got to do it 100 more times, right? And so you open up the factory and you begin trying to do the same thing at scale. And it really is the difference between building one car, which is not an easy, mean feat, and then building 100. And as you cross into the new contexts, the new requirements start to come out. You've got different terrains, different workloads, different operating conditions that your product has to work with. You get new types of stakeholders, new types of customers, new managers and middlemen and tax regimes, and even your existing customers may change. As a long project goes on, there's many kind of scaling issues that we begin to hit, and new limitations, even of the tools and technologies, begin to become apparent. And this is the point where we usually begin to talk to customers around digital maturity, because everybody wants to be up here. For right-hand corner, to be optimizing and automating, they want to have remote operations, lights out manufacturing, golden recipes, but that is tough. It's all about being able to both give analytics and decision support, but also to change the underlying processes that the business is using to be able to use the new tools and technologies. So in reality, we all begin here. Wow, there's a lot of data, but we don't really have it in one place. Then you store it, and you've got it all securely managed, but you're still not really using it. And you start building dashboards and visuals and be able to see what's going on with your equipment in real time. From there, you can begin joining it up with other systems to be able to see, right, how does that match up with my maintenance records or with my alarms database? How do I get better notifications of what's going on? You begin to enter some of the really kind of challenging stuff we've already touched on around getting better foundations for the data, getting it sanitized, getting it standardized. It becomes a lot more challenging. And this is the stuff that you really need to solve to be able to get all the way up the curve. If you're going to try anything around data science, GPTs, LLMs, AI, prescriptive models, all this sorts of stuff, your data needs to be solid. It needs to be standardized, sanitized, and carefully managed, because that's what these models need in order to train. If you're not training the models on good data, you'll get rubbish out of them out the other side. But the good news is that even if you're all the way on the left-hand side here, actually most of the value is pretty early on. That just from being able to access your data, visualize it, doing kind of core analytics on your data, that will get you most of your value. People, they often want to be up at, LLMs and AI and things like that, but the bulk of the value is often in just the essential equipment monitoring and early indications of failure and things like that. And we feel this curve in practice as you do any kind of project, that you get a lot of value out of the basics. As you start getting to more and more advanced stuff, it gets harder and the return on value can be lower initially. But then if you can push through it and get to the other side, that the newer capabilities become more possible. So it's just in whatever you're trying to do and however you want to try and benefit your business and look after your sensors and your equipment, it's trying to think, where is this on the difficulty scale and what do I need in order to make it successful? Let's make this a little bit simpler. Why is connected data important? It's not just a buzzword. Think about marketing for a second. If somebody has your email address, that's concerning. If they also have your name and job title, then they can begin personalizing communications to you. If they have your date of birth, your location. They can understand demographics about you. They can give you local targeted things for kind of where you are and what you're interested in. If they know your interests and hobbies, they can target them. If they know your purchase history, then your past purchases are a very powerful predictor of your future purchases. And finally, if you've been doing any kind of searching, they've got some active targets. They know what it is that you might be interested in today. And that's when you get your mobile app notifications. Oh, we thought you might like this. You might like that. It's getting quite scary these days because even kids apps and stuff, like they'll listen to background noise and see if they can hear the theme tune for Paw Patrol or Peppa Pig, and they will give you targeted advertisement based on what they can hear in the environment. So we've got to be very careful around how data is managed. Just as a total tangent here, if you've never seen The Social Dilemma on Netflix, The Social Dilemma, it's a really good documentary all about why data is used by big companies to target us and how they use that to influence us. So I strongly recommend that one, The Social Dilemma. But getting back on script here, thinking about your industrial data. For any sensor, you've got a value. You pair that with a sensor ID, you know where it's coming from. You've got a location, which unit or system or section is this affecting? What are the engineering units? What's the context and magnitude of my value? What kind of rich description do we have? Do we know exactly what it's measuring? Better yet, do you have any diagrams or other linked value? Is the value typical or is it extreme compared to the historic data? And can we connect it with anything else? Are there any alarms or maintenance records that could tell us whether this value is significant in what it's saying? And so this is why when we begin to think about large-scale data management projects and even doing anomaly detection at scale, thinking about how to join this data up becomes more and more important. And so before we close out the session, we just look at a couple of ways people do this today. It's not the same as it was 10, 15 years ago. Used to be you'd all have quite simple analytics. These days you see more and more data pipeline tools. So you might hear some buzzwords. You got like Apache Kafka, Spark, Flink, Databricks uses those. In Python, you've got Pandas and Dask, and even some of the common IoT platforms, your Azure IoT, AWS, Google IoT. These are all data pipelines that carry and transform that data and kind of pump it forward to wherever you need it to be. There's a real growth in what you call knowledge graph platforms. You don't really need to know all the terms and language, but you might be familiar with some of the platforms themselves. I mean, things like Azure Data Lake, Neo4j. There's Rockwell's Data Mosaics, Palantir Foundry, or Aviva's Connect Data Services. And Databricks that helps power a lot of that as well. These tools are effectively a single location you can gather all your information from. So instead of having to worry about grabbing data from all these different source systems, it's all being put into one place. So when you're building things, you can build from one stack. And this is great because it creates a robust single platform for your data queries, but there are risks. And especially, if you care about measurement and values, then you probably care quite a lot about what is the system of record for my data. You don't want people to be replicating and changing that data somewhere down the stream if that's not a valid transformation. So in all these things, as you see them beginning to be used with your data, you just got to make sure you understand what exactly is happening to my data and are we handling it effectively. But you don't have to do this. For a smaller organization, commonly use more enterprise visualization platforms that you don't worry with all the guff is too strong a word, but the challenges of doing data pipelines and knowledge graphs. If you're just happy, you're happy that I've got my source systems for all my data, my historian, SQL databases and PDFs and file shares, and all I want is to bring them together into one place. And so that's what kind of modern enterprise analytics platforms and enterprise visualization platforms are there for, whether it's things like PyVision, Power BI, Tableau, Grafana, even down to like Ignition and Asset Intellect these days. There are lots of platforms out there that specialize in gathering data together and making them useful in one place. And so It can still be harder if you really are at the high scale of things, but it does ensure that your source systems continue to be the source of truth, and it avoids, replicating and copying your data again and again, which can cause a lot of costs. And so, very quick example. Here is the Asset Intellect platform that I mentioned a moment ago, who we've taken a combination of our analytic detecting anomalies and put that side by side with the maintenance history for the same bits of equipment. And it allows us to begin to tie down the relationships between our anomaly detection and the other systems that relate to them, and allows you to push the end users forward to these other tools and using data where it belongs. So it's just figuring out, for whatever the end goal is that you're trying to achieve, that we're using the appropriate types of tools to handle that data. So to finish off, I'd encourage you, if you have any kind of relationship with any kind of digital projects, then I'd encourage you, please do whatever you can to help these things to be successful. Help them to shape and implement the standards. Help them to anticipate any complications that may arise. Help them to contain any scope creep that begins to happen, and to capture the value of your solution. And that last one I've underlined, because a lot of people go around building tools, but you got to make sure they're successful, that they actually do what you meant them to do. And so when you begin to deploy these new tools, and actually it does save you value, and you say, wow, it saved us from a compressor trip, or we were able to schedule maintenance for that before it failed. If you can begin to capture that and say, actually, that saved us, £20,000 or $50,000 or whatever it actually saved you, it helps you to understand where the value is really coming from, and then to make that case for the business. I think I built the slide a bit backwards. I've got a few bullets here. Having people who are passionate, or at least committed, convicted to making it work, is the strongest predictor of project success. Having you on board, having people involved who really want to see it work, is the key to getting it all working. And by doing so, you are then able to influence the outcomes of your projects. So hopefully we've covered a huge array of stuff. I know some of it will be relevant to you, some of it won't, but hopefully it gives you a better sense of how to run a successful digital project, or how to influence and enable them from wherever it is that you're sitting in the organization, and to ensure that you can get to that goal that you have of being able to detect anomalies sooner and manage your equipment more intelligently. So almost bang on 45 minutes, and happy to hand back for questions.
Yeah, thanks very much, Steve.